Awesome. Just waiting for everyone to trickle in here. Hey there. Awesome. Okay. Let's get things kicked off. If you are joining this session, welcome. This is the MLflow Community Meetup. I'm Carly, your host for today, and I'm so glad to have you with us, whether you're tuning in live on LinkedIn, X, or YouTube. We have a really exciting lineup ahead, featuring new innovations and integrations from the MLflow ecosystem that we think you're going to love. But first, just a quick reminder, MLflow is an open source project built by and for the community. If you are looking to get involved, there are a bunch of great ways. So let's talk about them. You can join the MLflow user Slack, connect with other users, ask questions, and share insights. You're also able to follow MLflow on LinkedIn, X, and Blue Sky. Stay updated on the latest news, events, and announcements. Also, explore the MLflow GitHub repository, report issues, contribute code, or suggest improvements. Lastly, you can find all upcoming and past MLflow events on Luma, including meetups just like this one. So before we dive in, a few quick notes. If you have any questions, drop them in the chat on the platform you're watching from. We'll be answering your questions live throughout today's meetup. If you miss anything or want to rewatch, do not worry, the full session recording will be available on the MLflow YouTube channel right after this event. Okay, now let's take a quick look at today's agenda. First up, we have MLflow DSPy Integration. Tamu, one of MLflow maintainers and an engineer here at Databricks, will walk us through how MLflow now supports DSPy workflows, covering everything from compilation tracking to enhanced tracking support and a sneak peek at what's coming next. Then we're joined by Chris from Cleanlab, who will share how Cleanlab can help you automate and build trust in your MLflow workflows, especially in high impact applications like AI and RAG pipelines. This is going to be a great session. Thanks again for being here, and let's get started. Turning it over to you, Tamu.
Hi, thank you, Corey. Hi, everyone. I'm Tom Hieter. I'm a software engineer at Databricks, and I maintain both MLflow and DSPy. Today, I will talk about the new integration we shipped in MLflow for supporting for improving the observability of DSPy optimizers. But before jumping into the actual integration details, because this is a MLflow meetup rather than a DSPy meetup, I will spend some time to describe the basic of DSPy. Okay, what is DSPy? DSPy is a Python framework to build a modular language model agent. You can use DSPy framework in Python to build your AI agent, and the DSPy offers a lot of functionality to support your agent workflow. Okay, so here's a basic overview of DSPy. So DSPy consists of DSPy programming and offline program optimization. The basic background of DSPy programming is that prompt engineering is very time consuming. But actually, in the if you look into the actual industry use case, you will see a lot of prompt files like this, which is cumbersome and which is not efficient basically. So with DSPy, you can use DSPy signature or modules instead of manual prompt. This is an example for building an emotion extraction workflow using the language model. So traditionally, you have to build your text prompt like you can see is the left side, long text with a lot of manual instructions to the language agent. Then your output is also just a string, like a long text. Then you have to pass it by yourself with like manual programming. This is time consuming and not efficient. So instead of doing this kind of like prompt engineering, you can use DSPy and write your workflow with true Python modules, like the example you can see on the right side. So this is our DSPy signature. You can the one of the core component of DSPy is signature. So signature describe your like basic of your workflow, and what it can describe what is the input, and what's the type of input, and the same for output, what's the type of output, and what's the semantic of output. Then once you define the DSPy signature, you can easily use it with DSPy modules. And here in this example, I'm using DSPy Predict, one of the simplest module of DSPy. Then you can define your AI agent just with signature and the DSPy modules like this. Then once you build your agent, you can pass the input to execute your workflow without any manual prompting. All right, let's move on. So now I talked about DSPy programming. Then I will next talk about another component, which is DSPy optimizers. DSPy optimizers can optimize multiple aspects of your language model agent. It can optimize instruction, it can optimize future examples, and it can also conduct language model fine-tuning for your language model weights. In terms of the instruction, I think everyone knows that instruction is very important. Instruction means task description, input-output description, and also response formats and so on. Then in the center, we describe the future examples, and it's a lot of studies shows that language model can learn from future examples, and if you pass high quality examples, that will lead to good response quality. But however, because there's a trade-off between the cost and the quality, you want to find good future example rather than many examples. Then lastly, DSPy also supports language model fine-tuning. So it is not applicable when you are using a remote model like OpenAI API or Anthropic API. But if you are calling your language model on your local environment, DSPy allows you to fine-tune with your model by supervised fine-tuning or maybe like policy improvement. Just a moment. Okay, so here's a very high-level diagram of the optimization. So to optimize your language model agent, we need these three components: training examples, evaluation metric, and DSPy program. Then once you have all of these three, you input these three items into DSPy optimizer. Then you can get the optimized prompt eventually. There's a question from the committee. Can you walk us through a real-world example of using the MLflow with DSPy? What kind of language model optimization workflow benefits the most from this integration? Yeah, that's a good question. I will talk about the actual examples and what you can do with ML4 and DSPy later. So yeah, I will come back. Okay, so now I will talk about the components of optimizers. So one of the main components of optimizers are instruction proposer. So instruction proposer is a component to come up with instruction candidate using DSPy program training examples and tips. So DSPy offers several built-in proposals. Then it consumes your DSPy program and the several training output you inputted and also tips you provide. Then proposal use language model behind the scene and produce instruction candidate, which will be used for the optimization process. Then another component is bootstrapping algorithm. So this is for selecting a good bootstrap examples. Then bootstrap algorithm will take in DSPy program, training example, and the metrics. Then DSPy offers multiple bootstrapping algorithms, and you can use it to select good examples. Well, these two are the main components of DSPy optimizers. We offers various advanced optimization algorithm. And then here you are seeing MLflow optimizer, one of the most popular optimizer in DSPy today. And our research shows that MLflow, one of the advanced optimizer, successfully achieves the improvement of language model agent through prompt and await optimization in multiple datasets. Okay, so from from now on, I will start talking about the new integration between MLflow and DSPy. Okay, so as you can see, as you have seen, DSPy optimizers have accomplished the improvement of language model agent across multiple datasets and tasks. However, it has been unclear for users how your DSPy agent is optimized, and it's not easy to record optimization experiment. So on the left side of the screen, you are seeing there one of the example of using MLflow optimizer for our basic benchmark. Then when you run, so using DSPy optimizers is very simple. You can define, you can import the optimizer and call the compile method of the optimizer with your program train set and several hyperparameters and the evaluation metrics. Basically, that's all. However, once optimization is completed, you can get the optimizer program and the low log text. However, the problem is you can get the final output, but you don't know what happened inside the optimization process. So it's very difficult to debug, and it's very difficult to understand if your hyperparameters are good or not. So and this problem is very difficult to overcome because of the black box nature of DSPy optimizers. For the traditional deep learning, like PyTorch or TensorFlow, we overcome this problem by inserting MLflow instrumentation, like the example on the left side. You can insert log metrics, log params, and so on to record your parameters and metrics and so on, or maybe artifacts to enhance your traceability or observability of your training script. It was possible because in the traditional deep learning, this is you who writes the training script, and the training flow is basically standardized. However, in DSPy optimization process and logic is written inside the DSPy framework, and as a user, you just call the compile method of the optimizer to execute the optimization process rather than writing a training script by yourself. Then it is not straightforward for you to insert the instrumentation logic to your training script. Loading. Okay, so here I summarize the user challenges. First thing is optimization trajectory. It was not easy to understand the overview of the optimization trajectory from the log text. The another thing is the general traceability. You can get the optimizer program and the like evaluation results after the optimization, but you have to save this information manually to MLflow if you want to increase the traceability. Then the third part is intermediate trial. Even though optimizers try multiple parameter set and prompt set, it was not easy to you to understand what kind of prompt are tried and what was the performance score. Then lastly, it was not easy to compare the program's output for each example before and after the optimization. So this is the motivation of the new integration. Then here's what we offer from MLflow. So we enhance the auto logging API. Traditionally, auto logging API of MLflow for DSPy only supports tracing. With enhanced API recently, we also support tracking functionality for DSPy optimizers. Then our methodology for increasing the traceability of DSPy optimizers is inspired by our strategy for the traditional hyperparameter tuners like OpTuner. For hyperparameter tuning, we create a MLflow run, root MLflow run for the optimization process and create multiple child runs for the intermediate hyperparameter set. So we will do the same for DSPy optimizers. We create a one MLflow root one root MLflow run for the optimization process itself. Then for each intermediate prompt, we create our child runs for each with score, prompts, and traces. Then on the parent run, you can see the trajectory of your performance score, and it will be visualized in the MLflow UI. And lastly, by utilizing the existing evaluation tab, now you can compare the output for individual example before and after the optimization. Here's an example of the ML4 auto tracing API for DSPy optimizers. And this is all you need to add to your DSPy experiment code to enable this auto logging. For now, I will walk through the information tracked by MLflow for DSPy optimizers. First of all, when you open the experiment page, you can see the parent run and the child run hierarchically. We create one parent run for each optimization, and we create child runs for each evaluation. Then, when you open the parent run detail page, you can see the optimizer hyperparameters, optimizer prompt, overall performance trajectory, and train eval dataset. Particularly, we believe this performance trajectory is important and useful for users because it was not easy to visualize this kind of information from the log text with DSPy only. Next, when you click into the child run, you can see the prompt of the intermediate program, evaluation score of the intermediate program, and the tracing of each program execution. Loading. Tracing is a helpful feature to enable you to understand the behavior of your DSPy agent in detail. So when you click the traces tab of the child run, you can see the list of traces. Then when you click one of the traces, then you can see the detail of each trace. Now this is particularly useful for debugging. And lastly, but not the least, we provide the functionality for example was comparison. If you go back to the experiment page and click the evaluation tab, you can select the evaluation result artifact and compare the output of your program for each input before and after the optimization. This is useful for understanding what kind of behavior has changed throughout the optimization process. All right, that's all for today's presentation for the DSPy and MLflow integration. Thank you for listening, and please try out our DSPy and MLflow integration and give your feedback to us.
Excellent. Thank you so much for walking through that integration. We do have a few community questions that I'm going to put on the screen here very shortly. So the first one here, how does tracing in MLflow enhance debugging and evaluation in DSPy workflows?
Yeah, great question. So, like for example, I will explain like my actual use case. So maybe like this image a bit too small, but when you open the trace view of the MLflow UI, you can see the spans, span information for each layer of the DSPy agent execution. Basically, DSPy agent consists of multiple layers. The first layer is a DSPy module, which is like a chain of thought or predict and so on. Then inside DSPy modules, you have adapters and language models. So if you observe like a weird behavior from your DSPy agent, you might want you might be curious like what's the actual what's the raw output from the language model. Then it was not easy to look into it with only DSPy, but with MLflow tracings integration, you can actually open this view and check what's the actual output, raw output from the language model, and in which layer the language agent failed to convert the output into useful information. This is like one of the ways to debug your model with MLflow. And for the evaluation, this like I think you might already know that MLflow offers MLflow Evaluate, which is a common functionality for multiple flavors to easily evaluate your Gen AI models. But DSPy also has its own evaluation methodology. And for the optimizer tracking specifically, the DSPy evaluation like a methodology is used inside the optimizers. And it produces a result table. Then the result table itself is actually uploaded to the DSPy tracking server, MLflow tracking server with auto logging. So you can actually see the like artifact downloaded to inspect the actual like output and the individual score of your AI agent. I hope that that is helpful for answering your question.
Awesome. Thank you so much. And that will lead into our next question here. Thank you for submitting. Keep them coming. Can this integration support multi-agent or modular agent architectures and LLM pipelines? If so, how are versioning and prompt management handled?
Yeah, that's a good question. DSPy, so the short answer is we usually don't support the multi-agent, but we definitely support the modular agent architectures. DSPy itself is designed for supporting the modular agent architecture rather than like simple input-output agent. And the DSPy optimizer algorithm supports optimizing the prompt set for your agent modular agent architecture, which means instead of optimizing each language model call, it can optimize the combination of prompts for your modular agent. And then how you version and management handled. Okay, so with DSPy, there's a methodology to save your set of prompts for your modular agent into JSON or other file type. And it's actually executed within the auto-logging. So when you try the auto-logging with MLflow, you can actually see in the MLflow run, these kind of like set of prompts are saved into the JSON file, and the JSON file is saved as an artifact of the run.
Perfect. Thank you so much. We have another community question here. Is there any overhead or configuration required to enable MLflow tracking in DSPy projects?
No. As I showed in I forgot the number of the slides, but it's actually around here. Basically, that's all for what you need. You can just add these 2 lines to enable the auto-logging to DSPy optimizers, and you don't need to do anything further.
Awesome. That's great. We love that. And I guess finally here, how can the community contribute or provide feedback on this DSPy integration moving forward?
Okay, there's mainly 2 ways. You can either file, I think you can either reporting it to the DSPy side or MLflow side. And fortunately, I'm the maintainer of both. Either whether you submit a report to DSPy or MLflow, it probably comes to me, and yeah, I can pick it up. So feel free to find a ticket for the GitHub repositories, or maybe we can you can reach out to us through this kind of office hours, or maybe we have several social media, so you can reach out to us through social media as well.
Awesome. That's great. If as more questions trickle in here, we can address those at the end. But for now, I think we are all set. Tamu, we can transition over to our Cleanlab presentation.
Yeah, sounds
thank
great.
you so much.
Yeah.
Awesome. Okay. That was a very smooth transition over to this. Let's get to your slides here. Perfect. All right. As mentioned at the start, Chris from Cleanlab is going to share how Cleanlab can help you automate and build trust in your MLflow workflows. Thanks so much, Chris, and I'll let you take it away.
Awesome. Thanks, Carly. Hey, everyone. Nice to meet you all. Thanks for your time today. My name is Chris. I'm a data scientist here at Cleanlab. First, let's set a quick agenda of what we're going to cover. So first, I'll talk about what is Cleanlab, who are we as a company. Then we'll look at how do we at Cleanlab solve AI reliability problems. And then finally, we'll look at how can MLflow users actually utilize our technology. So first, let's start on the first bullet point. What is Cleanlab? Here at Cleanlab, our goal is to make AI agents and RAG systems reliable. And we've been lucky enough to partner with a couple hundred of the Fortune 500 companies in this AI reliability and RAG space, Gen AI, et cetera. So then now we'll talk about how does Cleanlab solve these AI reliability problems. Now, our main solution focuses on LLM, RAG, and agents. So at the core of the majority of our customers and clients have this system in place, whether it's an LLM, whether it's a RAG system, whether it's an agential system, or some combination of all those 3. What we do is we have this kind of Gen AI reliability layer that sits around this core functionality with these 4 different components. We're going to focus on this detection piece today, which is most relevant to the MLflow users, but just wanted to touch on kind of at the company level what we're doing today and kind of what's new in the Cleanlab world. So on the detection side, we're able to automatically detect these inaccuracies caused by retrieval or contextual or hallucinatory responses from these AI systems. Then we prioritize those and aggregate them and rank them, etc. So that when you actually correct these and resolve these problems, you save as much time as possible. And then also there's a prevention step also that basically takes these problems and issues, and once you correct them, applies those to future issues. That way you're saving time, etc. And this kind of flywheel approach is what we've built around this internal core LLM RAG and agential system. So like I mentioned, we're going to focus on the detection piece, which is kind of most relevant to LLM traces and the MLflow platform. So at the core, if there's one thing you take away from today, it's that Cleanlab detects wrong LLM responses and saves you time to actually find those bad responses. On the left-hand side here, you can see this quick query. What's the third month of the year alphabetically, right? A seemingly simple question that humans would get pretty easily. The correct answer is December. But we actually see here in this response, and this response is just it's a GPT-4o response hosted on our website. You can find this at chat.cleanlab.ai. It's a publicly facing UI to kind of tweak and play around with our technology. So we see here the response, and this is a GPT-4o, responds with the third month of the year alphabetically is April, and then actually lists them in the correct order, but obviously gets that answer incorrect. And if you try this a couple different times and vary the query a little bit, sometimes it'll get it right, sometimes it gets it wrong, sometimes it's very confident it gets it wrong. But at the end of the day, this is a query that is seemingly easy, but is actually very tough for LLMs to answer. And if this type of question was in a production system or a RAG system or in a generative AI system, you'd have no idea or no way of knowing that this answer is actually incorrect. So what we do is we flag this response with this trustworthiness score here at the bottom. In this case, it's 0.362, which that flags this example as hallucinatory or inconsistent or basically just bad. And then you can decision programmatically based on that score, however you see fit. This is an example of an hallucination that we detect. We also detect a couple other issues kind of in the RAG world, such as wrong context. So if your knowledge base has the correct answer, but the RAG system can't find it, we detect that with a certain score. And then also knowledge gaps if your RAG system or database doesn't actually contain the information required to answer the user's query. We have basically an ensemble of scores that you can use to detect these different types of issues in these RAG and agential systems. Cool. So now we'll hop into, second, go back. Cool. So now we see, great, we have these scores. How can we trust Cleanlab? What makes our scores better kind of than anybody else? Here's a couple benchmarks that we've publicly shown. We have a bunch of benchmarks that we've publicly published to show kind of our technology and how it works. On the left-hand side here, this is a RAG use case. And in this case, we're looking at the AUROC metric, where we're comparing Cleanlab to other commonly used evaluation kind of frameworks or metrics like LM as a judge, or RAGAS is an open source one, hallucination, GEval, et cetera, et cetera. And this is all publicly available. We can post some links later. But in this case, Cleanlab outperforms these other evaluation metrics quite substantially. And then on the right-hand side here, this is a kind of a classic classification binary task where we have these different Q&A data sets, and we're computing, did the LM get the answer correct or not? And with Cleanlab, we see that these numbers outperform these other types of kind of commonly used metrics like log probs, LM as a judge, which is a very common one these days across the board. Cool. So now we've seen kind of what Cleanlab does, how it works. Can we trust these scores? Let's look at how MLflow users can now utilize Cleanlab and these scores to actually decrease the time it takes to find these bad LM responses in their data. So let me share my screen here. Awesome. So we should be, okay, good. So we're going to start in the notebook, and we're going to kind of hop back and forth between this notebook and the MLflow interface. So in this setup, this notebook, what we're going to do is we're going to set up some of these trivia questions, and then we're going to generate answers to these trivia questions using OpenAI, and then trace those OpenAI calls with this MLflow autolog. So just basically one line of code that logs, all of the OpenAI query prompt to response calls. And then once we have those queries, we're going to evaluate those queries with Cleanlab technology, and then look at those scores and see how we can get those scores back into the MLflow interface, so you can then sort and find examples of bad LM responses. So we first start by just generating, the answers to these queries. So we have a couple here that we'll look at in a second. In this case, we give it a system prompt. You're a trivia master. answer this question, et cetera, et cetera. Pretty simple setup. So then if we hop back into the MLflow browser here. Perfect. So now we're back in the MLflow UI. So what we've done is now we can see that these traces are now logged in the MLflow UI. There should be 5 of them here. And in this case, there's only 5. But if you imagine in a production use case or in a big system, you may have hundreds or thousands of these queries, right? And you have no idea of knowing, are these prompt and response pairs good? Are they bad? How are we performing? Are they hallucinatory? Should we trust them, et cetera, et cetera? So now we're going to show you how we can get these evaluatory and these trustworthiness scores back into the UI in the notebook. So let me hop back into the notebook here. Cool. So now here back in the notebook. And what we're going to do is we're going to download those traces from MLflow in just a few lines of code. Here we're going to search for the traces and then download them into our local environment. Here we set up our Cleanlab TLM, and TLM is our trustworthy language model, and that's what's used to evaluate these prompt response pairs. Just a few lines to import that here. Then what this function is doing is we're going to get the prompt and response pairs from those set of traces. So baked in the traces, we have a bunch of metadata, and all this is doing is parsing that metadata out so that we return a list of all the prompts, including the system prompts, and then a list of all the responses that the OpenAI API returned for us. And all we need to do to evaluate these is pass these prompt response pairs into this get trustworthiness score method, and it will automatically return and evaluate scores and explanations for all of these prompt and responses automatically. So in this case, when you have 5, this could be 5,000, 10,000, et cetera. And what we do is we extract those trust scores and explanations from these evaluations, and we just toss them into a quick data frame, and we can then show you how we have here. Now we have the prompt response pairs here. And now we have this trust score and explanation that Cleanlab has added automatically. And typically what we see our customers mainly use this for is you can sort by this trust score, and then basically you're surfacing all of the bad responses and bad LLM outputs to the top. That way you can then spend your time actually fixing the prompts and responses and modeling agential flow, whatever it may be, RAG system. And you're focusing your time and saving time by not just finding these issues, but then actually being able to fix these issues now that you know kind of what's going wrong here. So now we have these scores and explanations for each of these rows here. We can quickly upload these evaluations back into the MLflow platform just in a few lines of code. We set the request ID, and here we're adding the trust score and the explanation back into the MLflow UI. So if we hop back over into the MLflow window, we can see if we refresh our page and we now add the tags column here, we can now see how for each of these prompt response pairs, we've now added a trust score and evaluation, or sorry, an explanation to each of these rows. And let's look at one here. So this is a really low score, right? So 0.03. We can look, if we click into this one, this is the same question, right? What is the third month of the year in alphabetical order? We see that the OpenAI API returned the answer for March, which is obviously incorrect. And now based on this score, we now can detect that, oh, this score is very, very low, 0.03. This is probably an hallucinatory, incorrect, inconsistent response. What this allows you to do now is now at the macro level, you can scroll through all of your traces and very quickly find examples of traces that are very, very bad. Here's one that's actually correct. What is the capital of France? And the assistant responds with, or OpenAI responds with, the capital of France is Paris. We see here how that one has a very high associated trustworthiness score. Awesome. So that's the kind of general integration. It's very easy to kind of add the TLM or the TLM code into your kind of evaluations and then upload those scores back into the MLflow UI and very quickly and easily find those bad responses. Let me hop back into this. You want to pull the slide back up, Carly? Perfect. And awesome. So if you guys want to learn more, we can post the blog link, which kind of outlines the entire integration end-to-end. It has an associated notebook with it. So if you want to run through the notebook, you can do that. You can also try out Cleanlab today, either in the UI at chat.cleanlab.ai. It's free to use. You can go play around with it and see kind of how the trustworthiness score works. You can also use it via the API at tlm.cleanlab.ai. And then also, if anybody is building RAG or agential systems that are in production or trying to get in production, if you'd like to talk about how Cleanlab as a company can help you, feel free to reach out at cleanlab.ai/contact.
Excellent. Thank you so much, Chris. That was awesome. We do have a couple of questions that trickled in from LinkedIn here. So let's get started. Okay. So can Cleanlab flag low confidence predictions or highlight areas where models need more training data? How does that tie back into data collection strategies?
Yeah, great question. So at the core of the trustworthiness score, part of the there's multiple pieces that go into the score. One of the pieces is looking at the unknowns of the model. So is this model not trained on enough data to actually provide an accurate response? And that is a piece that's baked into the score. So a low score can indicate that, yes, this model has not been trained on enough information to provide a correct answer. And that will be kind of just very easily known by a low score. And then how does that tie back into data collection strategies? Well, I think if because the technology is meant to be run at scale, right? So if you have hundreds or thousands or tens of thousands of responses that you're trying to evaluate, and you're able to then group those by the trust score, if you take the subset that has a very low score, you'll probably start to see patterns and be able to evaluate, okay, this subset of data, our model is performing very low on, and then you can then collect more data to train better models based on that subset.
Awesome. Great answer. Thank you. So another question here, can you version or audit Cleanlab outputs using MLflow's experiment tracking features?
Yeah, absolutely. So in the bottom of that blog, if you go to that blog link, there's two other sections that talk about using the evaluation piece of MLflow, and then also tracing TLM directly. So both of the features are available, and you can definitely use the experiment tracking features to then version and audit those different outputs of Cleanlab.
Awesome. I will make sure to get this out, this link to wherever you're tuning in on. So look out in the comments and there'll be a link direct to this. Okay. What else do we have here? Oh, here's a kind of a fun one. What's on the roadmap for improving or expanding Cleanlab's integration with MLflow? Are there any upcoming features to keep an eye on?
Yeah, I think the cool thing about the integration is you really as MLflow improves as a UI, and then also as TLM improves and Cleanlab improves as a company with our technology, both of those kind of synergies will work together without actually needing any other integration. The way the integration works now is really you're able to extract that information from MLflow and then do the evaluations and produce those metrics locally at scale on your data, and then re-ingest those back into MLflow. So as both of those technologies get better, the integration will naturally get better as well.
Perfect. Great. And another great question. How does Cleanlab handle noisy labels in production environments? And follow-up question, can MLflow help track and visualize these corrections over time?
Cool, good question. Yeah, so on the labels front, the Cleanlab platform can definitely be used to detect mislabeled examples, especially in text data. If you're using GenAI and LLMs, typically you would use a prompt template to determine, okay, here's my data point, here's my given label, and then basically, in natural language, is this label correct? And then based on the trustworthiness score, you can then quickly find examples of label issues within your production data. And the second piece, can MLflow help track and visualize these corrections over time? I'm not sure, actually. I'm not sure if MLflow has a functionality, but I'll let that be a follow-up. Oh, Carl, are you muted? Or is it me?
Sorry. Flipping in between tabs here, pulling out the questions. But I see here, someone's asking for some real-world use cases around this integration. Are there certain subject matter areas where TLM performs really well, or is it totally general purpose? So the question is real world use cases for TLM in general.
Yeah, absolutely. Yeah, so we've benchmarked and optimized TLM to be applicable to many different verticals and use cases, and even domain-specific use cases as well. Since we're kind of built on top of the LLM layer, so as LLMs naturally get better, our trustworthiness scoring will also improve as well. So we've seen in the finance sector is very common, banking, customer support. Yeah, those are just a couple to name a few, but yeah, very general purpose and applicable to even kind of niche domains.
Great. Thank you. And let's see here. I think we have just one last question for you. How do you track and visualize Cleanlab's impact on model performance using MLflow? For example, can you compare runs before and after applying Cleanlab corrections?
Yeah, so I believe in that evaluations piece, you'll be able to compare different runs with your model. So, for example, if you have one run prior to Cleanlab, and let's say you have a set of data that you're trying to clean up using for a few shot prompting or whatever it may be, you have one run before without Cleanlab, you then use Cleanlab's TLM to find those scores and produce a better model. And then in the evaluation tab, you should be able to compare those directly together.
Perfect. And just as I said that, we had another question come in. Can you use TLM for A/B testing different models?
Yes, absolutely. That's definitely one use case that is very common because you have that pretty objective score, and you're actually able to choose the underlying models that produce that score as well. So let's say you have model A and model B, you can actually use a third model C to evaluate those models, outside of model A and B all entirely, and you get kind of a pseudo objective evaluation to compare directly. Okay, is model A doing better? Is model B doing better? And one concrete way to do that is, let's say you have an evaluation data set. You produce a trustworthiness score for every example in that data set, and then you can just average that trust score and see kind of over the entirety of the data set, how confident is the model in its predictions.
Awesome. Okay, I think that is the last question. Yeah, you're going to need a sip of water, Chris, from all those questions. That was rapid fire. So we really appreciate all of your responses there. Thank you so much. And so I think if there are no other questions, and feel free to drop them in as you think of them at a later date. We can always respond to you over whatever chat channel that you are tuning in from. So I think, we have one more question, actually. Okay, one more. Awesome. Thank you. Can evaluations be done around responsible AI?
Yeah, and I think I know what you're talking about. So I'll try and give a good answer. I think it's more on the kind of AI kind of safety ethics side of things. I think it's what's being asked. Yeah, absolutely. So one of the elements that we built into the TLM model is actually in a custom evaluation function. So if you dig a little bit deeper into the API, we have a feature that allows you to define your own metric, and it could be an arbitrary metric. An example of is this response biased, or does this response contain violence or anything like that? And then it'll provide a secondary score on top of the trustworthiness score to evaluate that response through the lens of that custom evaluation. And that's just a natural language, just a written sentence. So it applies to arbitrary kind of any guardrails or anything you'd want to add to that system. We definitely support.
Perfect. Great. Thank you so much. I think we can close out today. Tamu, if you'd like to say farewell to the audience here. Awesome. Thank you so much. I'll just put up this slide number 3 again, which is how to participate in MLflow, and just a few closing thoughts here. This wraps up today's MLflow Community Meetup. A huge thank you to our speakers, Tamu, Chris, Thank you for sharing your insights and giving us a look into what's new and what's possible with MLflow. And of course, thank you to everyone in the audience for tuning in, asking questions, and being part of the MLflow community. If you'd like to keep the conversation going, here's just a few ways to get involved. Join the MLflow Slack, connect with MLflow maintainers and users. You also can share your ideas and feedback in GitHub discussions. And of course, you can try out the latest features and contribute to the project. Just a friendly reminder, we do have our next MLflow office hours on Tuesday, April 29th at 4 p.m. Pacific. Feel free to bring your MLflow questions. We have MLflow maintainers ready to help troubleshoot them with you. Check the chat for a direct link to the registration page. I will drop that shortly. Whether it's morning or evening where you are, thanks again for joining us. We will see you next time. Until then, take care and happy experimenting.